Alright, so we're taking a look at the Hackboard2, starting with an unboxing. So this is a Celeron-based single-board computer that started as a crowdfunding type thing on Crowd Supply, which apparently isn't particularly a great platform for these sorts of things, but I guess it is what it is. It's from either early 2021 or late 2020, so it's quite a bit long in the tooth. Mine just arrived today, so this is October 2023, and so it's been, just about 3 years since I backed this thing, which, crowdfunding things often take a while, and then, we have COVID and global part shortages and all that fun stuff. But anyway, let's take a look. So yeah, for starters, this box is enormous. This is what came from Crowd Supply, which my understanding is that they're using Mouser for fulfillment. So maybe this is just Mouser doing enormous packaging, because I just ordered the base model machine, not not any extra bits, because they can sell it to you with like a monitor and a keyboard and all sorts of stuff if you wanted them to, I guess. Let's see, get that out of there. This is the weirdest box. Wow. Okay, well, that is a very big box. Again, for as big as this thing actually is. Tear the plastic off. So, move the camera in a bit closer here. You can see specs printed on the box. Comes with a heatsink. I'll take a look at that in a minute. This is the configuration I ordered, which is the 4 gig RAM, 64 gig SSD. I'm not going to do anything too wild and crazy. They have a version that you get with Windows 11, but I have no interest in running Windows on one of these things. So we've got a foam little pullout, and then here we go. So, got the board itself over here. I'll get that in a moment. Power supply. This is one of these pretty generic ones. 12 volts, 3 amps. It doesn't have a brand, but we'll put the US plug on it. And this is why I was joking about the heatsink. This is the heatsink they provide. You can buy a case with it, but I did not do that. Let's put this tray foam back in the box. And then I'll probably just toss this out, because I don't need any of this. See what I can recycle and get rid of it. Okay. Here's the board. Let's see. Pin out. FCC compliance. Quick start guide. A couple of silly stickers. Oh my, a bunch of silly stickers. Why are there so many stickers? I don't know why there's like letters and numbers. That's just weird. Okay. Quick start guide is pretty much, yeah, unpack it and plug it in. Yeah, same specs that were on the box, maybe a little bit more detail. And then I'm kind of, this is, the pinout's the same on the quick start guide and on this little slip. I don't really like this because this is identical to the Pi, both the layout and how they're numbered, like GPIO 17, 27, 22. Those are numbered the same way on the Pi. But in software, in Linux or in Windows, you're not gonna, there's not the Raspberry Pi GPIO library to help you map those out, right? You're gonna have to know at the hardware level how those map. And they haven't provided any of that documentation yet. I've requested it, but I haven't seen anything from them yet. So let's get the board open. So here we go. It's a very simple little single board computer. I actually have the Raspberry Pi on hand, so I can show how it compares. Here's the Raspberry Pi. It's a little more than twice as big as a Raspberry Pi. So let's see, I/O wise, we've got 3 USB 3 on the side. I'm pretty sure they're just 3.0. Power, which is just 12 volt, a 5.5 by 2.1 barrel jack. USB-C, which cannot be used for power delivery, and I don't think it can do video either. And then HDMI. We have our CPU. It's a Celeron N4020. Our 2 RAM modules here, which are AI Win modules, 16 gigabit each. So that's 2. 16 gigabit. Wouldn't that be right? Okay, yeah. So each one of those is 2 gigabytes. And then on the bottom, we've got our our SSD. This is the 64 gig SSD. I believe this is NVMe. We'll have to double check. There's no eMMC on board. The standard Super I/O controller. This is actually a SIM card slot if you wanted to put a cellular card in there. And then there are 2 flat flex connectors on the bottom edge. One for EDP, for DisplayPort, connecting a screen directly, and one for it's just USB. It's USB. It's for a touch panel. Also on the bottom of note is the Wi-Fi adapter and the antenna, which is just one of these little flex antennas with 3M adhesive on the back. And that's it as far as network connectivity. There is no Ethernet on this. Originally, there was supposed to be an Ethernet port right here, but they yanked it because of supply chain issues. They couldn't get the interface that they wanted, which is kind of a bummer for me because I wanted to use it for timing related stuff and timing related stuff over either a USB Ethernet adapter or over Wi-Fi is kind of a joke. So I don't know what I'm going to use it for now. I guess I'll still have to figure that out. A couple other things. They ship it. It does have a real-time clock, but they ship it without a battery. I'll zoom in a little bit. Oops. Yeah, they ship it without a battery. And the reason for that was because originally they were supposed to be shipped via airmail from their manufacturer in China to the US. And I guess you can't provide batteries when you do that. So there's a little sticker here that says that the CR927 is not fitted. So I purchased some, just pretty cheap. I want to say this was like $4 on Amazon. And but what's kind of funny is that the shipping process ended up getting screwed up, and they were shipped instead via they were shipped on a boat, and so it took a lot longer, and it could have been fitted. So go figure, just a weird little thing. As far as interfaces on the top, other than the standard ports, There's a hardware power button, which is kind of nice. There's a fan header. I haven't figured out what all of these connectors are yet. I've asked the creators to provide some information, but I haven't heard anything yet. We can see some standoff holes around the corners, which will be nice for, if you want to 3D print your own case or whatever. You'll need to lift it up a little bit because of the way the M.2 slots are just kind of hanging out on the bottom. And so we have a fan header, which is just two pin. I think it's just straight 5 volts uncontrolled. There's your 40-pin GPIO, which you may notice something kind of weird about it. Then here's a 10-pin battery connector. And again, I don't know anything about that connector yet either. I believe it's the same. One of the Latte Pandas also has a 10-pin battery connector. Maybe the same. I don't know if you can get off-the-shelf batteries that use it. I don't really understand why it's there. And then there's a USB 2 port there as well. And to be honest, pretty much everything about this board feels like they took a reference design for a low-end laptop like a Chromebook and just put it on a single board. It's got Wi-Fi, it's got the battery connector, it's got the flat panel connector, it's got the display port for a flat panel screen, it's got the touch interface, it's got a USB header that you could imagine going to a keyboard or trackpad. It got HDMI, got a couple USB ports, got a single USB-C port. This feels like an Intel reference design, Celeron N4020, with the added benefit of the Super I/O chip, which handles things like power management and temperatures and fans and serial ports, parallel ports. Also has a bunch of GPIO, and so I would imagine these pins are routed straight up to this. And so as I said, that you might notice something a little bit weird about it. If I hold it up next to a normal Raspberry Pi, which again is about half the size, you'll see these pins are a lot smaller. So if you have a hat, like here for example, I don't have a full-size hat, but I have one of my little GPS modules, and it can just, plunk right down on the Raspberry Pi hat interface like that, no problem. The Raspberry Pi uses the standard 1/10 of an inch or 2.5 millimeter pin spacing. This guy doesn't. I think maybe this uses 2 millimeter pin spacing. I'm not entirely sure. What's funny though is that I believe it's the same that older laptop IDE hard drives use. And so, for example, here I have an adapter for old laptop IDE hard drives to go from the smaller interface to allow you to connect it to a full-size ribbon interface. This is just a straight-through adapter. Unfortunately, I can't use it because one of the pins is blocked, but it does otherwise perfectly match this. And if you could find one of these that doesn't have that pin blocked, you could use it. I could pop it on like this. Here, I put it on off center. This isn't electrically correct at all. And then I could put on a hat. So I'm like, ta-da! So it's very inconvenient. I mean, it's pretty clear that the GPIO on here is an afterthought. This whole pin header is an afterthought. Like, yeah, it's Raspberry Pi pin compatible, wink wink, but who cares? They haven't provided any documentation on it. It's not even clear how it's oriented. I'm not even sure which. Okay, I think that is pin 1. So hats would be oriented like this, extending off to the left side of the board in this orientation. So yeah, I don't want to be too hard on it. It's just a little bit of a disappointment given both how long it took and to get here, and also it changed a lot in the development process, and it's just an N4020 single board computer. I will say, I only paid I think $90 or $99 for it when the crowdfunding thing opened. Now this variant, I think, is like 160 or 170 on, like you can buy them from Micro Center. So, you know, that's just something else to think about. I'm sure I'll find something to do with it. But not having dedicated Ethernet is a drag. So, yeah, so with that, what I'm going to do, we'll go ahead and fit the heatsink. And it's just got a thermal pad that covers the entire bottom of the heatsink. So there's all sorts of sticky that's going to get crudted up under there. Plunk it down. Some folks on Reddit have actually already reported having thermal issues in Debian. So I'm going to do some testing of that. So heatsink is plunked down. And then I think I've got some standoffs. I really don't want it sitting on the NVMe card, so I'll put some standoffs on it to raise it up a little bit, and then hook it up, and we'll see what the BIOS looks like and the out-of-box experience for the software looks like. Okay, it's been a little while, but I've got everything pulled together, so let's hook this thing up. Also, slight correction, this power cable is not 5.5 millimeter by 2.1 millimeter. It's 5.5 millimeter by 2.5 millimeter. Hi, Marco. So just keep that in mind. Other 12 volt high amperage power supplies may not work if they don't have the right diameter, inner diameter. All right, Marco, I gotta put you on the floor, buddy. All right. So let's plug it in and see what happens. I have not plugged it in yet, but I've connected a keyboard, HDMI to a display that's right up here. I'll pan up to it in a moment. Got the clock battery in. Plug it in. We got a green LED there, a red LED there. If we get video, I'll pan up to it. There's no documentation as far as what these mean. I don't see anything on the screen though, so I'm guessing green LED means power good, red LED means turned off. So let's click the button. It's not getting warm. Let's hold the button. Oh, hold the button, it turns blue, red goes off. I'm gonna go ahead and pan up to the screen, because I think that's where we should be seeing. All right, Hackboard. Can I get into BIOS? Escape. Because that is what I'm interested in. I'm not interested in Debian right now. Escape, F1, F2, delete. Okay, whoop. One of those got me in. All right, let's set the date and time. October 3rd, 2023. Time is 15:26. All right, so let's take a look at these BIOS settings. So the build date and time, April 12, 23. I'm not sure how well you can see this. I know it's kind of a wacky angle. AMI BIOS, blah, 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 UEFI, 4 gigs RAM, trusted computing, blah, 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 ACPI. ACPI auto configuration is disabled. I want that enabled. That's weird. Smart settings, smart self-test, that's fine. Serial port console redirection. I don't even know if this thing has a serial port yet, so it has pins marked UART transmit and receive, but I don't know how real they are. Oh my gosh, Marco, buddy. Currently running at 1.1 gig. It's an N4020, blah, blah, blah. Nothing. Huh. The thermal digital sensor is disabled. I'm going to enable that. Don't know why that would be disabled. Okay, only one graphics output. SIO configuration. I can't open that, so I'm not sure what that is. PCIe hot plug, USB configuration, network stack for EFI. Ah, no NVMe device found. So that tells me that is not an NVMe drive. That's actually a SATA drive. TPM, security configuration, thermals. Wow. Quite. This is a pretty wide open BIOS. PS2 keyboard and mouse. Not even present. No USB on here, or no PS2 rather. A lot of debugging stuff. That's kind of interesting. TDO GPIO pen. Not sure what that is. Ultrabook support. Yeah, again, like I said earlier, I really think this is a a Chromebook or a small low-end laptop. Just designed OS selection, Linux. Yeah, right now there's only audio available through HDMI, and even that has some issues, apparently. They're waiting for some sort of a patch from Intel. Yeah, so sure enough, the included drive is a SATA drive. It is not an NVMe drive, which I actually think... Oh, where did I put the documentation? I think they specifically say... I'm looking at the specifications here. Oh no, that's interesting. They actually specifically say M.2A is a 64 gig eMMC SATA, and B, I don't know. Yeah, right there. Huh. Interesting. So the thing, they say it has NVMe, but I'm wondering if that's not actually true. If it doesn't actually have NVMe. Huh. Interesting. Okay. Well, I'm not going to make any changes, but that's good to know. GPS device, BCM 4752. I'm getting the impression that there's a lot of junk in the BIOS that they've just left wide open. That's strange. LPSS device configuration. But there is a codec device, INT343A, that is enabled. That's an I2S audio interface. I don't know if that's what is providing the audio over to the HDMI port. I'm going to search INT343A real quick. Realtek hardware audio codec. Huh. Okay. I don't know where that's situated. If that pushes audio into the HDMI port, I thought that happened on the CPU, but Secure boot is disabled. Yeah, this looks pretty straightforward. But I didn't see, there's usually something in here for hardware to monitor the thermals, but that might have been, since it was disabled, it's not there. Let's save and exit and kick over to Debian. The heatsink feels warm, but not hot. It's not bad. While it's booting, I'll pull the camera down and show you. I put it on, I found some standoffs. I think these are just M3. So the NVMe slots aren't, or the M.2 slots, I guess I should say, aren't riding on the desk directly. Alright, let's get back up to here. This thing is not quick to post. Okay, well, I guess we're back. I'm not sure what happened, but I turned it off and pulled the battery, and I guess that reset all the settings. I guess I changed something in the UEFI that it didn't like, so I just redid it, but all I did was set the date and time, and here we're just at Debian Grub, so we can see how long it takes to boot. This is Debian 11, so it's a slightly older image. I don't know if it has a GUI installed. I guess I can plug in a mouse if it does. It does have a GUI. Okay. Surprisingly, it looks like they've configured this with KDE. Default session is Plasma. That's odd. Default credentials are, the user is Hackboard. The root password is HB2. Well, I'm not logging in as root. I'm logging in as the Hackboard user. Okay, it's HB2 in all caps. So, guys, for future reference, you have to specify the password for that account, not the whatever. All right, we got some goofy wallpaper here that's like a edge detected photo of the board. We got Wi-Fi scanning for networks automatically. That's nice. Let's see what's in the home directory. Or is there anything remotely useful? I'm going to assume nothing in downloads. Huh. Somebody was poking around in the apt sources. Interesting. They've got it configured to use the Huawei the Huawei sources for updates. I didn't even know that Huawei was a repository. That's interesting. I don't particularly care, but I know that there are a lot of people that are sensitive to that. Let's open up a terminal. Nice and big. Make the font nice and big. Oh, I guess I should zoom out. There. I was curious if they have any special modules loaded. Doesn't look like anything out of the usual. Let's do this. Nope, not that one. Our internet's actually down right now, so I'm connecting to my hotspot. Okay. Okay. CPU reading 54C, Wi-Fi reading 38. The heatsink feels warm to the touch. It doesn't feel that warm, so I just don't know if that's the heat. It's not working that effectively, or what's going on there. It's a file, not a directory. Okay, they don't have any specific modules loaded in there. That looks pretty normal. Ugh. Pop over to dev. So under dev, there are 4 GPIO chips, 0, 1, 2, 3. Clock. Yeah, I'm gonna have to do a little bit more digging around to figure out what's going on as far as the interfaces on that 40-pin header. But there are 4 GPIO chips defined. There are 4 TTYs defined, hardware TTYs. Yep, just the one disk. I can never remember where all this stuff is. Okay, so there's the GPIO chips. Yeah, we just need more documentation to do anything with that. Huh. Yeah, I certainly wouldn't have configured this out of the box with KDE, but it is what it is. So, I don't know. I guess it works. The Huawei mirrors are very interesting. But there's no data on here. There's no, useful information. Just the wallpaper. Oh well. Was hoping for some documentation, but nothing to see. So I guess, yeah, just some more testing to be done and see if I can reproduce any of the thermal issues that other folks have seen. And that is about it. It's a little x86 single board computer. It's a little bit limited, but there it is. It exists. All right, so this video is already getting kind of long in the tooth, especially for like an unboxing first look video. But there are a couple things I wanted to address. It's been a little bit since I've started, and I've done a good bit more digging, so I thought I would just share a bit more information. Specifically, I'm going to talk a little bit about thermals and what I've found out so far about GPIO. So, here's my system. it's running, it's just idle, it's not doing anything right now. We can see the ambient temp in here is 24C, 75F. And on the system itself, it's not doing anything again, it's idle. I have a loop running the sensors command, checking the package temperature, so that's, you know, combination of both cores. And it's hovering between 39 and 40C, which is fine, right? And then what I'm going to do is, if we need it, I have a little USB-powered fan. And what I'm going to do is I'm going to run basically a compression load on the system. So I've got this text file here that's about a gigabyte of text from Wikipedia. It's commonly used for compression tests. And I'm just going to use the XZ command to use all threads to compress this file. Right? And then we'll see what happens temperature-wise. Now again, before I run it, this is the bare board with the provided heatsink. It's 24 centigrade in here right now. The fan is not running. There's no additional cooling, and there's no real airflow over here. So this is just running in a pretty stock, you know, whatever heat gets generated is just going to radiate off and convect out on its own accord. So let's go ahead and run this command and see what happens to the thermals. All right, so it's running. It's going at about 2 megabytes a second, and the CPU temps are climbing fast. 65, 66. I've seen it get pretty high. I think the junction max is 100C for most Intel CPUs. And then something else I'm going to do, let me split this one. So let's periodically check the CPU speed. So every 2 seconds, it's going to update the CPU speed. So you can see both cores are still running at 2.7 gig. Now the maximum boost frequency for this CPU is 2.8, I believe, but I haven't seen it hit that. It's normal, like stock speed is 1 gig or 1.1 gig. But you can see it's still running, it's still compressing, and it's getting hotter. You know, we're hitting 80C. So some folks have noticed thermal overloads and, you know, automatic thermal shutdowns at much lower temperatures, like as low as in the 60s. I have encountered that myself once. Curiously enough, it was when I was installing, I believe it was Rocky Linux. Just kind of out of nowhere, the installer shut down, and I saw before it rebooted on the screen, it did flash a thermal overload warning, like a kernel message warning. But here we can see it's hot, you know, it's climbing, but it's still running at 2.7 gig. And, you know, the compression job is still running. It hasn't crashed. And the CPU package is continuing to climb. You know, hitting, looks like 86C right now. And that may be as high as it gets for this run. When I tested it the other day, it was a little bit warmer in here. I want to say it was like 27C in here. Oh, there, 88. So I don't know how long we need to run this. We need to leave it running, but just to show that it's, you know, it can happen. It can be sustained for a couple of minutes and not shut down. So I don't know why it does for some. I don't know if it's an OS configuration. I'm not really sure. I wanted to kind of let this keep running until it hit peak temperature, and it's still climbing. So there's 90. I didn't see it get above 92, I think, was the maximum I saw it hit when it was running last time. So I'll give it another minute or so, and then I can call it. So there's 92 briefly, kind of wiggle it around. And then what I'll do, let's tilt back down here. So here's my little USB fan. And just from this distance, you know, what's that, 8 inches. Temps should drop relatively quickly. This may be a little bit too far, but they are falling. So that's, you know, that's a good sign, I guess. A small amount of air can really temper this situation. The next thing I want to do is figure out exactly what type of connector is used on the board for the fan. And then I'll get a small 40 millimeter fan and just plunk it down right on top of, you know, right on top of this little heatsink, and it'll be fine. So let me exit out of all this stuff, cancel that, and close out of this. All right, so I think I had mentioned, you know, there are these 4 GPIO chips in the device tree, and if you install the GPIO tools and run GPI info, which isn't compatible with less because of, oh, there you go. So it tells us basically nothing. It says GPIO chip 0, 80 lines. All of them are unnamed. Chip number 1, 80 lines. All of them are unnamed. You know, a mixture of input, some outputs. GPIO chip 2, 20 lines. GPIO chip 3, 35 lines. You know, so if you run a command like this on a Raspberry Pi or on a nicer ARM single board computer, these will usually be described, and it'll tell you what their pin name, you know, the actual pin name, and then what it's used for. And in this case, there's nothing. So there's currently no way to map those pins, you know, to something in software, right? From a hardware perspective, I did manage to get this guy to work because it turned out that one pin on the 2 millimeter spacing side was just blocked. So it was really easy to poke through that little bit of plastic and set it right down. It's just, you know, if there's one pin missing, that's fine. In this case, I've got one of my little Raspberry Pi hats running. And this is a good example because it uses both UART, I2C, and a GPIO pin. And there's nothing, no signs of any of those, right? So, you know, if we look at our TTYs, we have 4 hardware TTYs, S0 through 3. None of them are mapped to what this little document describes as TXD and RXD for GPIO 14 and 15. They're just not there. They're on the, so on the bottom of the board, on the bottom of the machine is the Super I/O chip. They're there, and I'm thinking about, you know, finding the pinout for that CPIO chip and finding where these 4 TTYs are on there physically, and then seeing if any of them map out, and maybe there's just some separate software issue. But right now, those seem to go nowhere. And if we look at dmessage, we can see, so I just grep dmessage for TTYs, we can see those 4 TTYs. You know, we can see that they're the 16550A type, which is what's on that chip. You know, we can see their IRQs, their base baud rate, all that good stuff. So they're there in hardware. Linux knows they're there. They just don't seem to be mapped to this GPIO pinout that they provided us. The other thing is I2C. I've installed the I2C development tools, but there are no I2C interfaces on the machine that are accessible to us. So, actually, you know what? I say that, but I don't think I ever loaded. Okay, hold on. I might be lying here. Oops. Okay. So you maybe found something? Aha! Okay, well there's a bunch of I2C interfaces. So let's check real quick if any of these map to GPIO 2 and 3. So on my little GPS board, I have a real-time clock connected to I2C. So let's see. Sudo I2C. So it's not on that, not on that. A lot of stuff on number 9. And the device we're looking for is number 668, 0x68. Okay, I think that's it. Yeah, 0 through 12. So we just scanned 0 through 12 quickly, and my RTC didn't show up. So again, on this document, this seems to be incorrect. That it says there's an I2C bus on these pins, but it's not there. It's not actually there in Linux when we probe all of the buses or interfaces, whatever you want to call them. So I don't know. But to be honest, I very much have the impression that this thing, yeah, it's got a 40-pin GPIO interface, and the power and ground are, you know, where the document says 5 volts matches the 5 volt pins and 3 volts is on the 3 volt pins. But using any of the, you know, I2C or SPI or UART or GPIO, I don't, there's literally zero information on how to actually do that. I've reached out to the Hackboard folks a couple times about this and gotten absolutely nothing in response, so I really don't know what to say. But, you know, I'm going to keep hacking away at it and see if I can figure out. I mean, it wouldn't be too difficult to just, for example, set every single GPIO pin to be an input, and then to feed it a high signal, and then to just programmatically scan through every single one of those, you know, basically 200 GPIO interfaces, and try and figure out, you know, which one comes up high, because I really have no idea. So it's a little bit frustrating, but I guess it is what it is. So if you made it this far, thanks for watching. Leave me a comment to let me know what you think, and I guess stay tuned, because I'm not done with this thing. I'd like to do some more videos on it in the future, assuming I can figure out how to use the UART and the GPIO and anything like that, because otherwise it's just a, you know, it's basically a headless laptop, which is useful. It's got its own purposes, but it's less useful than if it had working GPIO and, well, especially an Ethernet port, but that's over at this point. So anyway, thanks for watching.